Good evening. Good evening, everyone. My name is Ken Ruscio, and I'm the president here at Washington & Lee, and I just want to welcome all of you, especially those of you from out of town and especially those from out of the country. The excitement here on campus today is, of course, your symposium. But it's also, as you might have noticed out on the front lawn, we have our law school commencement tomorrow. Hopefully right there on the front lawn. When you come out after this session, you might see a good old southeastern thunderstorm on the way. But we are privileged to have all of you here for this symposium. I can remember when Nicholas was here interviewing for the position that he now holds, the Johnson Endowed Chair that he now holds. And we were talking about things that he might do if he came here in that position. And one of the things that he talked about with great excitement and great animation was maybe a great interdisciplinary symposium with scholars from all over the world. Well, that sounded pretty good to us, and sure enough, here we are experiencing that reality. This is Washington Lee University, as you may have discovered over the last 24 hours or so, is a small but we think excellent institution. Our philosophy here is we find the best students that we can from anywhere in the world, especially here in the United States, and bring them together with the best faculty that we can find from anywhere, and not even necessarily the United States. And then we just kind of get out of the way. We really feel like that's the best way to foster a life of the mind, and we define a life of the mind in a whole bunch of different ways. Scholarship, of course, but very, very creative teaching. We are the 9th oldest institution of higher education in the United States. Depending on which record books you look at, we might even be the 6th, but we'll play conservatively and we'll say the 9th. I know to those of you who come from a different part of the world, in Europe, that doesn't sound as impressive to you as it does to a bunch of 18-year-olds from across the United States. 1749 is not quite that old for some of you, but at least in this part of the world, it's pretty old. And we take great pride in that. We think we'll be around for a longer period of time. What you are doing here today and tomorrow is doing the things that we like best, that great interdisciplinary, kind of creative, big idea stuff. And I was looking down the list of presentations and papers and essays that you all have written, and I thought, this is good scholarship from really good scholars, but it's also just really interesting. I mean, it truly, truly is interesting, fun stuff. So on behalf of all of us here at Washington & Lee, I wish you well for the rest of the symposium, and thank you very, very much for privileging us with being here with this wonderful, wonderful event. So thank you. And I'm now going to turn it over to Larry Betch.
Well, thank you, President Ruscio. My name is Lauren Betch. I also want to add my welcome to our distinguished guests and especially recognize the conference organizers, Professors Kostas Komporakis of the University of Geneva, Ron Numbers from the University of Wisconsin-Madison, and of course our own Nicholas Rupka. Now, I am the Director for International Education here at Washington Lee and a professor of Romance languages, so you may legitimately ask, what is he doing here? Well, my role here is really as the former, as a Director of International Education, because this conference for Washington & Lee is really much more than a gathering of brilliant minds to discuss and argue over important truths, or untruths, as you have laid it out to us today, related to the history of science. It is an example of what is possible on our campus within the scope of our current efforts to integrate global learning into the education of every Washington & Lee student. Your willingness to be here and to bring to us your international reputations and allow us to share in your expertise is, we anticipate, a forerunner of the kind of activity that will be taking place regularly on our campus as we implement our program initiatives and as we look forward to the opening of our new Center for Global Learning in approximately 18 months. So thank you all for inaugurating with us what we trust will become a hallmark of intellectual activity here at Washington and Lee. Our plenary speaker is well known to most of you. John Heilbron is Professor of History and Vice Chancellor Emeritus at the University of California-Berkeley, where among his many, many achievements, he created the Department of the History of Science. He's the author of 11 books, including his much-praised biography of Galileo and his most recent publication, Love Literature and the Quantum Atom. He's been visiting professor at Oxford and Yale universities, as well as Caltech, and a senior research fellow at Worcester College, Oxford. Now, Professor Heilbron is no stranger to controversy, and while his work elicits nearly universal praise, its most important aspect may be in the way that it provokes us to think outside what appears to be the obvious, to use our knowledge beyond science to understand better what science has to tell us. Let me offer a brief example. Professor Heilbron comments on Galileo's polemical treatise Dialogue on the Two Chief World Systems and observes that the mathematical inventions of the dialogue present serious problems of interpretation. And let me quote him. "These inventions are extremely clever, but evidently flawed if taken to be true of the world in which we live. Commentators tend either to interpret the cleverness as shrewd anticipations of later science or to condemn the shortfall as just plain errors. From my point of view, these marvels should be interpreted as literary devices, conundrums, extravaganzas, inventions too good not to be true in some world, if not ours. Mathematics, literature, philosophy, in other words, let's not leave Galileo entirely to the scientist if we want to begin to understand." Ladies and gentlemen, Professor John Heilbron.
Well, thank you, Larry, for your very kind words. And thank you all, dearly beloved, for coming here in such numbers. I also, of course, must thank the organizers for giving me the opportunity to participate in this extirpation of historical myths. And although this was not part of our bargain, for the opportunity to replace them with some of my own. Now, I'm only an apprentice mythoclast. I'm full of admiration, however, for the work of the professionals who during the last decade have identified and destroyed dozens of myths in the history of science. The titles of 3 recent books in English will give you some idea of the extent of the slaughter. Everything's Relative and Other Fables in the History of Science by physicist-historian Philip Rothman. Science Secrets, The Truth About Darwin's Finches, Einstein's Wife, and Other Myths by historian of science Alberto Martinez. And of course, Galileo Goes to Jail and Other Myths About Science and Religion by our own colleague, Ron Numbers. These books have disposed of 75 myths. Some 26 more are scheduled for annihilation at our meeting. That makes a total of 101, which is exactly the same as the number of myths in Ovid's Metamorphoses. It is hard to say why this should be so. But it's easy to explain how the history of science came to generate inadvertently as many myths as Ovid collected intentionally. It's because Numbers and the others define a myth as a mistaken claim. No doubt this usage set appropriately comfortable boundaries for their burgeoning new branch of mythoclasm. However, as the rapid rise of denounced myths suggests, their wide definition may flood the field with mere errors. A false claim that has lasted because no one has bothered to check its correctness is not ipso facto a myth. If our purpose were merely to seek out and attempt to eradicate mistakes in the historical record, we might more usefully have stayed home and extirpate Wikipedia. To err is human and only too easy. To make a myth takes work. To qualify as a myth, a false claim should be persistent and widespread. It should have a plausible and assignable reason for its endurance and immediate cultural relevance. The myths that interest me have an additional attribute. They must transmit a useful caricature or an inspiring illusion. Although erroneous or fabulous, such myths are not entirely wrong, and their exaggerations bring out aspects of a situation, relationship, or project that might otherwise be ignored. Niels Bohr, the inventor of the quantum atom, liked to say that the opposite of a deep truth is a deep truth. Just so, the opposite of a good myth may not be its negation, but its complement. As we need both a wave and a particle description to do justice to our fancied experience of the micro-world, we may deprive ourselves of the tools we need to explain the longevity of the old chestnuts we are gathered to roast if we take them to be no more than false claims. Most of my talk concerns three myths that meet my specifications. I have the effrontery to offer you: 1, the greatest myth in science and religion; 2, the greatest myth in physics; 3, the greatest myth of history of science; and 4, an Ovidian twist to the lot. The greatest myth in the history of science, according to Professor Numbers, is the claim made noisily by 2 American professors in the late 19th century that science and religion have been in a state of constant warfare. Taken literally, the claim is certainly false. There are countless cases where individuals practice their religion and their science without conflict, and where their church either tolerated or supported their efforts. The noisy American professors, one of whom was an historian and the other a chemist, chose to ignore periods of peaceful coexistence and co-prosperity. They had a flair for polemics and ransacked the professional literatures for effective metaphor. The historian Andrew Dixon White pictured the history of science as military history, as a sacred struggle against religion, with battles fiercer, with sieges more persistent, with strategy more vigorous than in any of the comparatively petty encounters of Alexander or Caesar or Napoleon. The chemist, John William Draper, saw the struggle as a problem in gas dynamics. For him, the history of science was a narrative of the conflict of 2 contending powers: the expansive forces of the human intellect on the one side, and the compression arising from traditional faith and human interests on the other. From the fact that science and religion have at times worked together, it does not follow that science and religion have always been friends, or could or can be collaborators. But it has been fashionable to say so. That, in my opinion, is to propagate a grosser and more dangerous myth than the terrible tale told by White and Draper. Their story, or better, the Enlightenment version as delivered by Voltaire and Diderot, is an enduring theme because, like a good caricature, it contains an element of truth usefully exaggerated. Science and religion are always potentially at odds. If and when they are not opposed in potentia, neither is living up to its fundamental commitments. They must be perpetually in potential disagreement because they are different belief systems anchored in different and conflicting authorities. We all know that educated people have believed that Scripture rules out various views about the nature and structure of the physical world and have acted on their convictions. Many still so believe and so act. To be sure, few, if any, officials of the mainline Christian churches now construe Scripture as a literal word of God, but there are many freelance exegetes who do. As I wrote these words, I had to hand the revised and corrected edition of A Geocentricity Primer by one Gerardus D. Bow, Ph.D., who claims to represent the International Association for Biblical Astronomy. The book dates from 2004. Like Galileo's antagonist, St. Robert Bellarmine, Bow bows before the unanswerable logic that if the Bible is the Word of God, and God does not deceive his creatures, every word in it must be literally true. And so, according to Bow, when Isaiah tells us that at the last judgment the Lord will remove the earth out of her place and set her to reel to and fro like a drunkard, we are to understand that until that time the earth will abide soberly in the place God assigned to it at creation. Even where religion has abandoned natural knowledge to science, it has reserved the right to interfere in its practice. Thus, several Christian sects, and not just fundamentalists, have sought to limit research using human stem cells. They believe that collecting and manipulating these cells raise grave questions about the nature of humanity and the rights of the fetus, and about the risks and ethics of medical applications. These questions, of course, lie within territory claimed by religion. Since aborted and superfluous test tube fetuses are the primary source of the stem cells of greatest interest, the ethics of their use touches the great socio-political issue of abortion. Churches opposed to abortion ruled it out altogether. The federal government, during George W. Bush's presidency, at first would not fund human stem cell research, and then under pressure agreed to support projects that used only established cell lines. I think this is just as it should be in a democracy. Organized religions should speak out against scientific work, especially if publicly funded, when they deem it contrary to their ethical commitments. The consequences are by no means always negative. Churches served as centers of opposition to the continuing improvement of nuclear weapons and helped to promote the test ban treaties. Some of them decried eugenics and unregulated cloning. Many of them advocate green causes and consequently challenge science policy that may result in increasing pollution, decreasing non-renewable resources, and accelerating climate change. It will not do to argue that these examples are beside the point because they concern not science, but its applications. These two form a continuum in which commercial exploitation is often a condition for the funding of relevant basic science. No more than applied religion, that is social pressure from faith-based ethics, can applied science be omitted from the reckoning of the relations between science and religion. It's particularly important in today's world when fundamentalism is on the rise and illiberal theocracies are ready to exploit every weakness in democratic regimes, that we recognize the perpetual, perennial, potential warfare between science and religion. This potential is often actualized in battles over school curricula. Promoting legislation against teaching evolution is a familiar American example. In Britain, at this moment, the teachings of Islam are being introduced into the schools in a few large cities as their Muslim populations gain influence over public education. Let us not replace the myth of constant warfare with one of inevitable peace in the relations between the two parties. The myth of perpetual conflict between science and religion inspires conflict and argument because it is supposed to apply always or for the most part. Most of the myths considered in the literature I referred to earlier, those 3 books, are not universal propositions, however, but assertions about particular episodes or fact. That need not make them impotent or uninteresting as myths. Some belong to the class of golden mean myths, identified by Claude Lévi-Strauss. They are stories designed to resolve tensions between equally strong but opposite claims. I'll mention briefly 2 such myths, which may or may not fit this definition. The first is the tale of the torture of Galileo by the Inquisition during his trial in 1633. This is certainly false if torture signifies inflicting only physical pain. There's no doubt, however, that Galileo was tortured psychologically. He probably was terrorized by his interrogators' references to methods of dealing with recalcitrant sinners, and he certainly suffered from confinement for life in his small villa and from prohibitions against talking and writing about his favorite subjects. So, though literally wrong, the story of Galileo's torture is psychologically correct. Thus interpreted, it is a golden mean myth. It has survived in its cruder form as a useful weapon in polemics against the Roman Catholic Church. My second example is the old chestnut that Columbus was the first or among the first to teach that the world is round, and learned churchmen attacked him for this fresh insight. This is, of course, a fabrication. It has this much truth in it, however, that Columbus was the first and perhaps the last to think that the earth is much rounder than God made it. Or, to speak plainly, Columbus insisted that the Earth's radius was about half what judicious evaluators of previous estimates and measurements supposed it to be. To suit his idée fixe, Columbus combined all the estimates that agreed with a small Earth and consequently argued against wiser heads that he could reach Japan by a 30-day sail west from the Canaries. The event proved both him and his adversaries wrong. Columbus had not got halfway to Japan before his 30 days were up, just as Isabella's advisors predicted. But neither had Columbus perished, because in 30 days he hit the West Indies. The myth that Columbus was the first to assert that the Earth is a globe reconciles the truths that his claims were bold and unprecedented, that Isabella's advisors were conservative, and that, as we might tell it to the National Science Foundation, venture capital is sometimes needed to break the mold of accepted knowledge. I turn to the greatest myth in physics. We must not overlook that science and religion have their fair share of myths. Choose for yourself among such splendid ones as Adam and Eve and the serpent, Noah and his ark, Moses and the Ten Commandments, the burning bush, Lot's wife, and much more. And also among the four elements, the vegetable soul, astrology, preformation, caloric, Freud and Jung, weather forecasts, and theories of everything. From this cornucopia, I shall choose the theory of everything, or is it known to its intimates, the TOE, or toe. It is not to be confused with a grand unified theory, or gut, which in the peculiar argot and anatomy of physics is part of a toe. Do you follow? The belief that there exists a full and rational account of the universe, and that human beings, or anyway mathematicians, are capable of discovering it, is the greatest and most inspiring myth of science. The pedigree of this belief is long and noble and lost in the sands of time before Thales proclaimed that all is water, and others on equally solid grounds declared for air or fire. They have their very distant descendants in some particle physicists of the last century and some string theorists today. Unfortunately, should they succeed in finding a toe, they almost certainly would not be able to convey the good news to ordinary human beings. Instead, we would be offered the super myth that the world is entirely comprehensible to people unable to communicate their knowledge to anybody else. I'm reminded of Thomas Carlyle's observation that there are people for whom devising a new universe is no harder than cooking an apple dumpling. Although, he continued, there have been minds to whom the question how the apples got inside presented difficulties. I'll mention 3 discarded dumplings before venturing a few words about current cookery in quantum cosmology. The first of the 3 old toes embraced Christian cosmology in its grand synthesis, and so brought about one of those synergies of science and religion that White and Draper excluded a priori. I have in mind the tight interdiscipline of theology and philosophy based on the Christianized Aristotelian cosmos, worked out by Thomas Aquinas and other competent medieval doctors. Aristotle's immovable mover, which did not create humankind and will not destroy it, indeed has no interest in us at all, became the creating, provident, benevolent, omniscient God of the New Testament. Aristotle's intelligences, which regulated and inspired the motions of the heavenly spheres, became angels. The incorruptible quintessence became the abode of the blessed and the angelic horde, and the world center to which, in Aristotle's views, all gross matter tends, became the obvious locale of hell. In addition, the Aristotelian doctrine of form and matter, from which Aristotle deduced in principle all the phenomena of the physical world, was used to formulate and dispute the nature of angels and demons, the sources of evil, the mystery of transubstantiation, and other remote conundrums. Although taken altogether, the synthesis of Christianity and Aristotelian philosophy was perhaps the biggest toe ever created. Regarded as an account of the physical universe, it was only a grand unified theory because it made a rigid distinction between the material and laws of the terrestrial and those of the celestial region. But it was just this grand unified theory that Galileo came up against when recommending Copernican ideas to the Roman Catholic Church. The inquisitors gave the problem to a committee of interdisciplinary experts who found that the Earth's motion was contrary to Scripture, that the immobility of the sun was rash in faith, and that both, such was the strength of the synthesis, both were absurd in philosophy, that is, physics. But the rigid distinction between heaven and earth, this gap between gut and toe, was a weak point at which Galileo and other heroes of the scientific revolution effectively aimed their blows. My second toe is the system of weightless fluids that constituted the basis of physics and chemistry around 1800. There were 8 or so of these fluids, 2 for electricity, 2 for magnetism, 1 each for heat and light, and also fire and phlogiston for those who still believed in them. The fluids in this 8-fold way were composed of particles that attracted or repelled one another in the manner of electric charges, that is, by the sort of action at a distance presupposed in the theory of universal gravitation. Its most important advocate, the Marquis de Laplace, made much of the transfer of distance forces from the heavens to the earth, from planetary gravity to electrical charges. The system of imponderables thus was a toe in appearance. All the forces of nature were brought into this scheme, although not even a gut in practice, not a grand unified theory in practice, for the only common property among these forces was their algebraic form. Advances in the theory of heat soon evaporated most of the weightless fluids and eliminated the distance forces they carried. Physics duly grew a new toe, based on the conservation of energy and incorporating as its gut Maxwell's synthesis of the theories of electricity, magnetism, and light. This 19th century theory of everything aimed to represent all the phenomena in the physical world in terms of matter and motion. In its most ambitious and far-fetched form, it foresaw a universe composed of primitive vortex rings swimming about in an omnipresent, incompressible fluid, just as smoke rings would do in air if air were frictionless and inelastic. Electric charges could be modeled as a permanent knots in this ether, an ordinary mass, as ether carried along by accelerating knots. Linked rings represented atoms, juxtaposed rings, molecules. On this model, a mathematician with infinite cleverness and no end of time would be able to calculate the course of the universe. As Maxwell remarked of the enterprise, the difficulties of the task are enormous, but the glory of surmounting them would be unique. But no one earned the glory of reducing the world to knots, vortices, twists, and turns in a perfect, frictionless fluid filling all space. Because physicists soon discovered that even the ordinary concepts of mechanics did not suffice to describe the goings-on in the microworld. which opened its doors to them around 1900 with the discoveries of X-rays, radioactivity, and the electron. The program of mechanical reduction fell victim to quantum theory, just as mechanical reduction had wiped out the system of imponderables. During the last 3/4 of a century, many brilliant people have extended the dominion of the quantum from the microworld to the cosmos. In the process, they discovered a few fundamental particles, and they made many, many more. A standard model, as it is called, reduced this particle zoo to a relatively few primary particles or progenitors. In its first draft, I want you to pay strict attention. In its first draft, the scheme required 5 pairs of primaries and their antiparticles. You'll need this fact later. The standard model incorporates 2 nuclear forces and electricity as well. That is, 3 of the 4 forces physicists recognize, the odd one out being gravity. A gut completed in the 1980s unified the first 3 of these forces. The unification was more fleeting than a sunbeam, however, as it ended during the first microsecond after the Big Bang, and nothing like the conditions that prevailed then have been seen since anywhere in the universe. The most promising approach for integrating gravity with the other forces into a theory of everything is superstring theory. This scheme lodges an infinitesimal elastic string within every fundamental particle. Calculating the wriggles of these worms and relating the results to anything observable make a task of the same exquisite difficulty and elusive glory as calculating a universe of vortex atoms. The theory presently operates in 11 dimensions of space and 1 of time. The tightly curled space dimensions we do not experience might be detected if we had a particle accelerator the size of the galaxy, or maybe of the universe. Estimates are a little wobbly in string theory. The little strings have no problem entering these tight dimensions, however, as they are rather small. 1/millionth of a trillionth of a trillionth of a trillionth of a centimeter, to be exact. Are we not in the realm of myth? I'm reminded of the story of Atlantis as delivered by Plato. According to him, 5 pairs of twin brothers, fathered by the god Neptune on a mortal woman, ruled the island. They exercised their power to create an infinite abundance of everything. The island was run in strict accordance with a single law laid down by Neptune at its creation. Who cannot see in this story a prophetic anticipation of the standard model? Like the first generation of Atlantis, the first version of the standard model derived infinite abundance from the activity of 5 sets of twins, the neutrino, electron, 3 sorts of quarks, and their antiparticles. The origin of the Atlantic twins in a single pair of ill-assorted parents is a grand unified theory. The inventors of the theory of everything that features superstrings cavorting in 11 dimensions seem to recognize the kinship with myth. They call their invention M theory. M for what? Not quite. M for magic and mystery, which are prime ingredients of myth. Although Atlantis did not exist, it had a place on medieval maps. And although these maps had little to do with reality, they helped inspire the voyage of Columbus. Building on myth and mismeasurement, he sailed beyond Atlantis and discovered America. The man who first proposed a state-supported institution for scientific research, Francis Bacon, located it on an island, and he called his invention the New Atlantis. There are now many such institutions. Some support theorists who, as they say of themselves, are trying to keep faith with the Greeks. Perhaps the theory of everything lies just over the horizon. Whether everything is water or everything is string, faith in the myth that everything is understandable keeps fundamental research fresh and funded. I come to the greatest myth in the history of science. It's that there is or was a history of science. By saying this, I'm not trying to be clever or subversive, but to call attention to the obvious truth that no plausible concept of science can cover the many sorts of natural knowledge developed since Thales discovered that everything is water. Histories of the various sorts of knowledge are not sufficiently parallel in content or method to fall into a single narrative. Thus, the concept, of the scientific revolution of the 17th century, or thereabouts, during which all sorts of natural knowledge went through the same or similar transformations at roughly the same time, cannot capture the situation, any more than a history of the German-speaking peoples can be reduced to the history of Prussia. The scientific revolution, which is the main episode in the history of Western science, has been a particularly fruitful historiographical concept because it is a metaphor as well as a myth. It inspired historians to look for radical changes, sharp breaks, revolutionary heroes, martyrs, slogans, eppure si muove, cogito ergo sum, nullius in verba, plus ultra, hypotheses non fingo, etc., etc. The metaphor of revolution goes well with the heroic view of history, which, as Carlyle put it in his off-putting lectures on heroes and hero worship, is a belief that progress in this world is affected solely by a very few great men. There is no better nursery for myth than the hothouse of hero worship. And so, the heroes of the scientific revolution have waxed larger than life and become the stuff that myths are made of. Perhaps the widest and most useful collection of such myths concerns the life and work of the great man on whom, more often than anyone else, historians have fathered the scientific revolution. This is, of course, Galileo, a modern Archimedes for his mathematical approach to physical problems, a second Columbus for his discovery of a new world in the heavens, and a new David for his slaying of the Goliath of Aristotle. According to the eminent historian of science, Paolo Rossi, the Galileos devised by modern historians divide into 8 major and 5 minor types. From this abundance, I have chosen 2 for further examination: Galileo the Platonist and Galileo the modern physicist. Galileo the Platonist is largely the creation of Alexandre Koyré, a brilliant linguist and forceful writer who taught the world that the history of science is more than a chronicle of the discoveries and inventions of unprejudiced minds. Not that Koyré looked beyond ideas for motivations. He began life as an historian of philosophy and wrote history as if ideas propagated themselves uncontaminated by anything else in the minds through which they passed. But these minds could be, indeed they had to be, prejudiced. Otherwise there would be nothing in them. Prejudice or preconceptions and the disputes to which they gave rise are therefore not to be despised by the historian, but teased out, analyzed into their components, and placed in a proper series, culminating in a painfully won discovery. The prejudice that filled the mind of Koyré's Galileo was the idea that nature is constructed on mathematical principles. Following out this idea, Galileo tried to transform natural knowledge from its preoccupation with causes to the more modest task of mathematical description. By luck and logic, he hit on his law of free fall, from which in time he worked out the geometrical trajectory of a projectile flying without resistance. This recondite information pleased mathematicians as it extended the scope of their subject, irritated philosophers as it diminished theirs, and made no difference to gunners who discovered nothing useful in Galileo's flight of fancy. As for Galileo's famous experiments with free fall, whether from towers or ship masts or oblique fall along inclined planes, they were either thought experiments, that is to say, pure fabrications, or inexact, after-the-fact demonstrations of conclusions Galileo had reached by reason and intuition alone. Koyré's caricature captured much of importance about Galileo's ideas about motion, without, however, betraying much about what moved Galileo. The bloodless caricature of a purely intellectual Platonic Galileo quickly became a master myth with profound consequences for the development of much of our field. In addition to its extension by Koyré and others to Descartes, Newton, and people in between, it inspired the researches and even the choice of profession of some of the founders of the academic study of the history of science in the United States after World War II. I.B. Cohen, Mary Boas, Charles Gillespie, Thomas Kuhn, and, for a time, Henry Gerlach. Koiré's caricature had particular appeal to people trained in physics who prized theory above experiment and science above society, and were content to let ideas breed without human intervention. The resultant Galileo was the one I accepted in graduate school under Kuhn's guidance. Being a responsible teacher, Kuhn also introduced his students to Galileo the engineer, as delineated by Edgar Zilsel, and to Galileo the modern physicist, as imagined by Stillman Drake and others besides. I gathered that these other Galileos were exhibited primarily as examples of the extravagances into which even good historians can be led by riding their hobby horses. Since Drake's Galileo has been as influential as Koiré's, and a better magnet for mythologizing anecdotes, I'll take him as my second example of Galileo caricatures. According to Drake, Galileo did physics in a manner differing only in unimportant details from the way in which Ernest Lawrence and his cyclotroniers were practicing it at the University of California when Drake was a student there in the 1930s. His main study then was philosophy, from which he came away prizing independence of thought and despising academic philosophers. The way to knowledge was to experiment with an open mind, confirm and reinforce the results, and try to subsume them under a mathematical law. Finding in Galileo's writings a clear statement of this method, and believing that Galileo had achieved his results by his rigorous practice, Drake recognized in him the first manifestation of the scientist in the history of civilization. This recognition implied a belief in the reliability of Galileo's reports of experimental results. Since the inventor of the tale of the Leaning Tower of Pisa, Vincenzo Viviani, claimed to have heard it from Galileo, Drake inclined to accept it. More importantly, he accepted Galileo's reports of trials on inclined planes that confirmed the law of fall to a hair's breadth and within a heart's beat. The possibility of this exactness could be tested. Several resourceful historians did so, and much to the surprise of Koiré's followers, showed that Galileo could have found his famous law by induction from experiments on inclined planes, just as Drake imagined that a modern student of physics armed with an Atwood's machine might do. Drake's approach inspired similar experiments to confirm the possibility of Galileo's experimental detection of isochronism of pendulums undergoing small oscillations. According to another anecdote transmitted by the practiced mythologizer Viviani, Galileo discovered this isochronism by counting his pulse while observing swings of a chandelier in the Cathedral of Pisa. The story can be improved by ascribing the swinging to an earthquake, and the discovery to Galileo's courage to pursue new knowledge in the face of grave danger. That's my contribution to the Galileo story. And once again, as in the case of the weights let fall from the Campanile, the opportunity was provided and the future adumbrated by making a piece of a church into an experimental apparatus. Drake's effort to establish his caricature of Galileo became a lifelong productive obsession. He turned himself into the chief authority on Galileo's manuscripts, translated Galileo's major works into English so good that Anglophone readers may easily mistake Galileo for a modern thinker. And he wrote many informative articles and monographs to confirm this impression. Drake's abiding interest, as he put it in the title of one of his monographs, was Galileo at Work. Drake's Galileo always follows the scientific method, never claiming anything he could not support by sensate experience and necessary demonstration. Consequently, Galileo was always right in his disputes, especially with Jesuits. And even his most extravagant speculations contain a grain or more of truth, later confirmed by Newtonian physics. In trying to support these assertions, Drake excavated important information that enriched the myth of Galileo the modern physicist. This was a useful corrective to Koiré's Platonist. It has the common sense appeal that contingent facts like the law of free fall cannot be found by thought alone. The propriety of the concept of the scientific revolution is often attacked, while its parent myth, that there is a single history of science, scrapes by almost unscathed. Indeed, the parent myth has prospered and enlarged as historians of the social sciences and of non-European natural knowledge have come to shelter under its umbrella. Perhaps it's a good thing that our fundamental myth remains vital. It is a grand unifying theory. It keeps the profession together, increases resources, augments impact, and inspires some excellent work. Although the writing of a coherent and universal history of science is as remote as a recreation of the Big Bang. I come now to a very short Ovidian twist. I conclude that our conference promises much more than the purging of persistent errors from the history of science. For if these errors serve or qualify as myths, they may imply something significant about the history they traduce. Indeed, they have helped to make history insofar as historical actors have believed in them. Thus it was and is with the fundamental myths I've discussed. The grand myth of incessant warfare between science and religion helped underpin the still powerful opposing submyths of value-free science and creation science. The grand myth of the Big Bang theory of everything, recently confirmed by the twitch of an instrument designed to detect gravitational waves of the South Pole, continues to drive invasive investigations into the birth and growth of the universe. The great myth of the history of science has produced in the scholarship devoted to the scientific revolution the most thorough and competent historiography in our field. Ovid's Metamorphoses teach that things are not what they seem. What you see as a cow might be Io, one of those fresh country lasses that Jove delighted to ravish. His wife Juno, who in the peculiar arrangement of the gods was also his sister, had her suspicions about poor Io. She flew down from Olympus to investigate. As she approached Jove's trysting grounds, His Majesty transformed the girl into a cow. Juno took a fancy to the animal and asked to have it. What could Jove do? Ovid describes his dilemma. It would be, he says, too cruel to give up his darling. Not to give, suspicious. Shame persuades, but love dissuades. Love would have won. But then, if he refused, his wife, his sister too, so slight a gift, a cow, it might well seem no cow at all. Ovid's accounts of transformations of men and women and animals are full of details calculated, as W.S. Gilbert makes Pooh Bah say in The Mikado, to give verisimilitude to an otherwise bald and unconvincing narrative. It's just this sort of detail that, according to the eminent historian of antiquity, Paul Vane, persuaded the Greeks to ascribe some truth to their myths. Thus, the importance in string theory, which has produced no result directly testable by experiment, of exotic numbers and plenty of details. But Ovid appears to have had a higher reason than decorating myths for his step-by-step descriptions of the transformations of people into animals. The last book of the Metamorphoses contains a long account of the philosophy of Pythagoras. This is not because of what Ovid describes as Pythagoras' account of the great world's origin, the cause of things, what nature is, what God, and whence the snow. Rather, it's because of the Pythagorean doctrine of the transmigration of souls. There is no death, Ovid has Pythagoras say, but only change. What we call birth is but a different new beginning. Our souls may return in animals. The ox, the farmer's brother in toil at the plow, may have been his brother in fact. Therefore, Ovid's Pythagoras thunders, abstain, eat not the flesh of your fellow creatures. Heed my message, abstain. Some unimaginative people have interpreted this injunction as a call for a vegetarian diet. They may be right, but it is more certainly a warning against the wanton slaying of myths. Therefore, I say unto you, take care. They might contain something of value. Heed my message. Things are not always what they seem. The myth you slay today may contain a truth you need tomorrow. Thank you.
Thank you so much, Professor Heilbron. That was a tour de force. Thank you so much. Thank you all for being here this evening. I remind you that I was going to say the slaying of myths, but of course I can't say that now. So the examination of myths, scientific myths, will continue tomorrow morning at the Stackhouse Theater. I hope all of you who are here this evening will join us sometime today, during the day tomorrow. We are adjourned.